So I have here everything that we need for this experiment, which is determining the concentration of copper in solution. So we're going to be using copper acetate to prepare our stock solution. So we have to calculate first how much of this compound copper acetate we need to prepare a solution with a concentration of 0.1 molar and a total volume of 25 milliliters. So once we have that number, we can weigh an amount that it's close to that number, not exactly the same, but something close to what we calculate. So I already did that part here, and I have my copper acetate, the amount that I'm going to be using for that stock solution. All the things that we have here are the volumetric flask. The first one with a total volume of 25 milliliters. This is the one that we're using for the stock solution. And then we have four volumetric flasks here, each one with a total volume of 10 milliliters. So these are the ones that we're using to prepare the dilutions, which are the standards. Okay? So we're going to be measuring the absorbance for these four dilutions here. Other things that we need is first the pipette. So with this pipette, we're measuring the volumes that we're using from the stock solution to prepare our dilutions. The pipette ball. And lastly, we have the cuvette that we're using with the spectrophotometer to measure the absorbance for our samples. So the spectrophotometer is already set up and calibrated using distilled water, which is going to be the solvent for our solutions. The last thing that I have here is the unknown solution that we're using. So we're preparing four dilutions or four standards with known concentration. We can calculate the concentration for these four. This is the unknown, which means that we don't know what concentration of copper we have in this solution. So the point of the experiment is actually use these standard solutions here with known concentration, measure their absorbance, prepare a graph, which is a calibration plot, and from that calibration plot, using the absorbance from this solution, we can actually determine the concentration of the unknown sample that I have right here in a small beaker. So the first thing is to prepare the stock solution. So you see I'm folding my plastic weighing boat. If you're using a weighing paper, it's easier, but I have this one here with my solid sample. So I folded it and I transfer my solid in here. There's always some solid that gets attached to the plastic boat here that I'm using. So we're dissolving this using distilled water. So I'm going to rinse that amount of solid, making sure that everything goes in the volumetric flask. Remember, this is the solution that we're going to determine the concentration. And from this one, we're preparing all the other standards. So I'm rinsing this small amounts of water because you have a total volume here and you have to make sure that all of that solid is dissolved before completing that volume to the 25. So I have rinsed all the solid, everything was transferred to the volumetric flask. So the next thing that I'm going to do, I'm going to add some more water. Your volumetric flask, they have a calibration line. It's right here. Okay. So that's the volume marking for 25 milliliters. So that's the total volume that we want. Okay. So total volume for your solution. I'm going to add some more water, but not all the way to that line. The reason is that you want for all the solid to dissolve before completing the volume to that 25 milliliters line. So I'm going to add some water. You can see that I didn't go all the way to the line. I still have some amount empty there. So I'm going to settle my volumetric flask to one side, and you can cap the volumetric flask and start mixing it until everything dissolves. If you complete the volume all the way to the 25 line mark here, and not all of the solid dissolves, when the solid dissolves, that volume is going to increase and it's going to pass that mark. Remember, your concentration that we're determining is the number of moles of the compound that we have, which is your solute copper acetate, divided by the total volume of the solution, and the total volume has to be 25 because that's what this volumetric flask here is calibrated to measure. Anything above that line, it's a volume that we don't know how much it is. It will be a volume higher than 25 and your concentration will be wrong. So I have here my stock solution, all of the solid dissolved, and now I'm in the process of completing the volume here all the way to the calibration line in the volumetric flask. So I have a small beaker here with distilled water and a dropper, and I'm going to use the dropper to make sure that I don't pass that line when adding the water. So instead of adding the water straight from the distilled water bottle, once the volume is very close to that line, we should add drop by drop to make sure that we get exactly to the line of 25 milliliters. So my stock solution is ready. So the next step is to prepare my dilutions here. So that's my stock, and I have here the pipette that I'm using to take the volume from my stock solution and to transfer that volume into the volumetric flask that I'm going to be using to prepare the standards. So I'm going to transfer my solution here from the volumetric flask into a beaker. It will be easier to take the volume from the beaker using the pipette. So we have to prepare for standards A, B, C, and D. You should label your volumetric flask so you don't get them mixed up. So I have my first volumetric flask for standard A, and the volume that I need from my stock solution to prepare my standard A is 2 milliliters. Okay? So we're increasing the volumes from 2 milliliters to 4 milliliters in the second one, 6, and in the last one, standard D, we're using 8 milliliters. So with this pipette, we can measure 10 milliliters. Okay? It's calibrated to measure 10. So for standard A, I need 2 milliliters, and then for standard C, I need 6 milliliters, and for standard B, I need 4, and for the last one, I need 8 milliliters. So if I do standard A and standard D, that will be a total of 10 milliliters, 2 and 8. So I'm going to fill this one all the way to 0 to have my 10 milliliters here. And then those 10, I'm going to transfer 2 of them for standard A and then 8 of them for standard D. So I'm taking in the volume from the beaker using the pipette, and I have all the way to 0 right there. So I'm going to transfer only 2 milliliters in my volumetric flask labeled as A. I have right there 2 milliliters, and then the rest will go to my volumetric flask labeled D. That's a total of 10. And I'm going to do the same thing for volumetric flask or standard C and standard B. For standard B, I need 4 milliliters. And then for C, I need 6, so that's a total of 10 again. So I will refill my my pipette here all the way to 10. I will transfer the 4 that I need here, and then the 6 left will be transferred to volumetric flask label C. So again, I'm finishing up adding the volume to the volumetric flask, the distilled water, to complete the volume all the way to the line of 10 milliliters. So once you're close to that line, we should use the dropper, adding drop by drop until we can see the meniscus align with the calibration line in the volumetric flask. Right? So I'm done doing that with this one, and I have all of my other standards ready, cap and mix, before determining the the absorbance for this solution. So the spectrophotometer, it's ready. I'm going to remove my blank here, which is just the water, and I'm going to transfer my sample into the cuvette, and then I'm going to put that in the spectrophotometer. We can fill the cuvette all the way to the mark that we have right there. That should be enough. Cleaning the cuvette using a Kim wipe to remove any fingerprints or anything. Placing here, closing, and we actually need this set up an absorbance. So the absorbance, this is with the blank, which is just water. This the water should be at 0. Okay? If it's in mode for transmittance, that will be 100% of the light that it's passing through, and then the absorbance should be 0 because the distilled water should not be absorbing any light. Okay? So now I'm placing my sample in there. We don't have to press anything. Okay? You have the sample, close the lid, and the number that you have here is the absorbance that corresponds to that first standard or standard A. So whenever you're doing your own experiment, you just need to copy the number that is in there. After you have that number, you remove the cuvette, you transfer your solution back into the volumetric flask just in case, rinse the cuvette, and then move to the second standard, which is going to be standard B.